Three billion times a day, P&G brands touch the lives of people all over the world. We make a wide variety of products, including Bounty paper towels and Crest toothpaste and Pantene shampoo. In fact, we have a diverse portfolio of more than 300 brands that are made and consumed worldwide. We sell products in 180 countries worldwide and have operations in more than 85 countries throughout the world. We're building more and more plants locally. They're multi-category plants within the regions and the markets in which we sell these products. And that's required a lot of global collaboration between our regional teams as well as global teams. In order to have an affordable, highly valuable consumer experience, each of our organizations have productivity and cost savings goals that they've met over the past years and are looking to improve in the coming years. We have, on average, improved our productivity 6% over the past 10 years, and that is more than twice the U.S. average and compared to other companies. We've used a variety of manufacturing simulation tools from a variety of vendors as early as the mid-1990s. But we started using plant design and optimization solutions from Siemens PLM software as early as 2006. One of our biggest challenges is the complexity of all the different flavors or colors and variations that we have on our products. And so having a tool that can really allow us to see what a shift of operation or a day of operation is going to look like, especially as we switch between a variety of product types for a particular flexible manufacturing system. That has been a big challenge, and we've been able to meet it with these types of tools. 3D has been very important to us in our layout process. Being able to use tools like Factory CAD has been very useful for our plant designers. Most of them had been familiar with AutoCAD and did 2D layouts. But that can be difficult for people in manufacturing or teams across the world to really understand what the 2D layout represents. By using Factory CAD, it becomes a library of parametric 3D tools within the AutoCAD environment that makes it very easy for them to learn and access since it's an environment they're already familiar with. And they can use these tools to visualize and create 3D representations of our plants before they're built. And that has been very useful to illustrate and understand different proposed designs. In addition to the plant being in 3D, a lot of our equipment comes from a 3D modeling tool like Solid Edge and can be saved as a JT file. And so we can get those JT files from different equipment vendors and place them in the layout. The placement of the equipment is very important to us. It can help understand how operators have access to the equipment or what locations we might be able to stage equipment or materials for the process. And so being able to visualize that in 3D in the context of the building can be very important to us. Material flow analysis is important for us to compare early on different concepts for the layout of the equipment. We use material flow analysis as a screening tool to compare option A to option B and quantitatively compare those and understand which one is got more feasibility or more potential than the other options we might be considering. Once we've identified which ones we want to go with, then we can bring them into a tool like plant simulation to really add detail, add a lot more complexity and data to the operation, and truly understand what it's going to be like to operate that equipment for a shift or a day or a week or a month. Given the variety of products, certainly sizes and formulations, as well as possibly different colors, a lot of the variations that we have in our products, plant simulation helps us truly understand and visualize what the operation is going to look like before we build that equipment. Plant simulation has been very efficient in its calculations, and so when we have, instead of making a couple hundred products which you might have in automotive or an aero, our projects are usually making thousands, often millions of products in a single shift. And so we needed to have a platform that could handle that number of objects within a particular world and be able to calculate those simulations fairly efficiently. In general, computer modeling and simulation has saved 17 years in design time in this past year alone. And we fully expect that in the coming years our productivity will increase from 6% to 7% to possibly 8% in the future.